Hi everyone, today in this video we will present our distributed system project, which is a microservice based smart healthcare platform. So the system supports three main roles: patient, doctor and admin, and provides functionalities such as patient profile management, doctor discovery, appointment booking, online payments, telemedicine sessions and notification. Then also we follow the microservices architecture where each domain is implemented as an independent service, as you can see, and all requests go through an API gateway which handles routing and JWT authentication. And for communication, we use the REST APIs for synchronous interactions and RabbitMQ for synchronous messaging, especially for notifications. The system is built using a MERN stack, containerized using Docker, and orchestrated with Kubernetes for deployment. Now, we will start demonstrating our healthcare platform member by member, where each will show the components they have implemented. Starting with authentication, here the user can either log in or register using JWT-based authentication. I will quickly demonstrate with the new patient registration. Okay, you can see the successful registration message, and we will be redirected to the login page. Now I will look into the created account, but first I will open the application layer so that we can see the JWT token getting fetched in the local storage. As you can see, the token is generated and stored on the local storage, and all protected routes are accessed through the API gateway with this token. Also here in the account settings, the user can change their password, update their name, email, and also to delete the account. Okay, for the patient service, I have implemented the full patient profile management functionality here. As you can see, here the patient can create and update their profile, including age, DOB, gender, blood type, height, weight, medical history, allergies, condition, all sort of medical related information can be included here and can be saved. Now I will quickly fill up the form. Okay, now when you save the profile, it will be saved in the database and you'll get the confirmation message above. Then if we move to the patient dashboard, we can see all the information we have given. I also implemented this medical report management function, where if a patient clicks on my reports button, patient can upload reports such as PDFs or images, and instead of storing files locally, I have integrated Cloud for scalable cloud storage, and when a file is uploaded, it is stored in the cloud in array, and only the name, category, and the file URL and the metadata will be saved in the database. Now I will demonstrate how to upload the medical report here, and as you can see, it is successfully uploaded, and we can view that by clicking on the view button. We can also open it in a new tab. That was an image, so now I will upload a PDF format report, and as you can see, it will also give the successful message, and we can view that here as well. And the patient can also delete their reports, and it will be prompted by a confirmation message, and that it's successfully deleted. And now if you visit the patient dashboard, you can see the patient summary with all the details, and also the recent reports that the patient has made, and you can view that on here as well. That covers the auth functionality and the patient service. Next, my team member will demonstrate the doctor.
Hello, I'm Nirvana. I'm responsible for doctor management service. First, user can register as a doctor. Then submit for verification. Let's try as doctor login. User can't login as a doctor until the admin verify the doctor. Let's login as a admin. This is the admin portal. I also implemented the admin part. Admin can verify the doctors in this section. This is the newly added doctor, and admin can verify him. And also admin have access in admin dashboard. Admin dashboard shows the user details, and admin can access user details and view details, and also delete the user. and also admin have access to appointments. Now admin verified that doctor. Now we try the doctor login. Now that doctor can log in. Verified doctors can log in. Unverified doctors can't log in the system. In appointment section, doctor can view the patient uploaded reports like this, and also can download it. And also, doctor can issue a prescription for a patient. And doctor can view the prescriptions that they issue first and can edit the prescription, and also can delete prescriptions. The delete button cancels the prescription, and if doctor wants to remove that prescription, doctor also can remove prescription. And otherwise, doctor have a my profile page to edit their profile, and they also can manage their availability by selecting a working day and selecting a time slot, and that slot it's very easy to handle and save the availability, and it's saved. In patient view, patient also can view the prescription that issued by a doctor likewise, and also can download as a PDF. And finally, it's the doctor management service can do.
Now I will explain my contribution to the system, which includes the appointment management service, its full lifecycle, and containerization using Docker. My part mainly focuses on how appointments are created, managed, updated, and processed across different states in the system. First, looking as a patient, go to the book appointment. So first, a patient can book appointment by selecting specific doctor, choosing a date. I choose 23, third, specific, and selecting an available time slot. When the booking is submitted, the appointment service communicates with the doctor service through the REST APIs to validate availability before creating the appointment. So I create appointment, then go to the My Appointments. Initially, every appointment is created with the pending status. This ensures the doctor has control over accepting or rejecting the request. So then in doctor dashboard, so we can see appointments. So once the doctor reviews the request and confirm it, the appointment status is updated to the confirm, and the update is reflected into the patient app. I will confirm, then go back to the patient dashboard. We can see status change into the confirm. And after the confirmation, the patient also has the ability to reschedule the appointment. They can change the date, time, or both, and submit it as reschedule request. We change the date to 4 p.m. and reschedule. Then once rescheduled, the appointment goes back to the pending state, and the doctor need to review it again. The doctor can then either accept or accept the new reschedule, reject it, or cancel the appointment. I can show you. Okay, doctor reviews and approve the new schedule. The updated appointment is reflected again in the patient dashboard. You can see update the appointment. You can see status change into the confirm. So after an appointment is confirmed, the patient is given a pay now option to proceed with the payment. Once the payment is completed, the doctor can mark the appointment as completed after the consultation. After the completion, the patient is able to delete the appointment record. The payment is completion process will be explained further by the next member. Additionally, from the admin dashboard, all the appointment details are centrally visible. This includes patient information, doctor details, appointment status, and payment status. This provides overall system monitoring and management capability. This service follows a microservice architecture where it does not directly access other service databases. Instead, all the communication is handled through the API gateway using REST APIs, ensuring loose coupling and scalability. So, for deployment, I containerize the appointment service using each service run in their own container with the allow independent scaling, better isolation, and easier deployment across environments. So that's complete the appointment service functionality.
Hi everyone, I am Varuna and I was responsible for the payment services, notification logic and telemedicine integration. As my teammate shows, once an appointment is booked and the doctor updates the status, my service takes over the final stage of the workflow. I implemented critical business rules here. The pay now button is dynamically rendered only after a doctor has reviewed and confirmed the appointment. This prevents premature payment and ensures the service is ready to be delivered. Integrate the Stripe API to handle secure PCI compliant transaction. Once the payment is verified, the challenge in a microservice architecture is displaying the result. Since the payment record only stores the transaction data, I implemented a triple fetch pattern on this payment history page to show the specialist real name and the exact time of the session. The front-end obstruction data in real time from the appointment and the doctor services. This join on front-end approach ensures we have a rich verified receipt for the patient without creating tight coupling between our backend database. To keep the systems scalable and responsive, I utilized RabbitMQ for asynchronous communication. The moment a payment is confirmed, the payment service publish a payment.success message to message queue. Our notification service consume this event to handle tasks like sending email receipts in the background. This event-driven design means the patient doesn't have to wait for an email server to respond. They can immediately move to the next step of their journey, the consultation. Finally, we have the Telemedicine service, which I integrated using Jitsi Meet. This service acts as secure gate for the entire platform. By verifying the payment status across the service mesh, the system only guarantees and unlocks the virtual meeting links for the appointment with the verified payment status. This ensures our clinical infrastructure is secure and accessible only to the authorized patients. By combining real-time API with asynchronous event handling, we have built a flow that is both scalable and highly reliable. Concludes our teammates present. Thank you.